So our idea, now you can ask your question again.
Of what?
Of what? Is we're going to try to develop an idea of population. Okay? We're going to do this in the dumbest possible way to start with.
Okay.
Which is to say we're going to look at the simplest population we possibly could.
2 sheep.
Which is not sheep, because sheep are big and complicated.
Hillbillies.
Amoeba. Atoms.
Sheep multiply quickly.
So
Eggs.
we're going to talk about single-celled things, which for reference will be depicted in such a way.
It's going to be some mitosis.
So here's some single cell. After a while, right, and this isn't about it, so a while isn't going to be particularly well defined. What happens?
They
Divide.
Yeah, they divide, and then there are
2 cells.
2.
Okay.
I think you totally nailed it. And then after a while,
You get
Four.
4 cells.
they each divide again, and then there are 4, right? Pay no attention to the fact that these are drastically changing in size. That's just because I'm bad at drawing circles. After a while more,
8.
there are 8.
And that's called exponential growth.
Oh yeah, and this is called exponential growth. Awesome. Okay, so this continues, right?
Yes.
You guys see that?
Mm-hmm.
This is kind of an inconvenient thing to continue, right? So I might start listing. First there was 1 thing, then there was
2.
2, and then there was 4, and then there was 8, and kind of so forth, right?
Right.
So how are you getting from step to step in this thing?
Double.
Yeah.
Yeah. So this is multiply by 2, right? This next stage is
Multiply by 2.
also multiply by 2. This next stage is
Multiply by 2.
multiply by 2. And now everyone's bored, right?
Yeah.
Because it's always
2.
multiply by 2, right? So this thing had a little bit more idea here. The idea that we've kind of glossed over is we started with something. What did we start with? 1. So we started with 1, and then we had a, I don't know, what do you call this thing?
Growth.
Multiply by 2.
Growth, maybe what would be a good,
Growth by 2.
Rate.
right? There was kind of a growth rate associated with this thing. What was the growth rate?
Did you hear that?
By 2.
Yeah, the doubling, right?
Yeah.
Okay, so this thing happens fairly often, and we actually give a good name to this. So I'm going to throw some words at you, but really all I mean is something like this, right? So I'm going to say a geometric sequence is a list, right? Which really has an order. Of numbers, like, and then what did we do? Well, we started with some starting value, right? So I'm going to call that A. And then how did we get from A, which was 1 in this case, to the next number?
Multiply by 2.
Multiply by 2. So here we're going to multiply by some other number, R. What's the R stand for in this?
Rate.
Rate, right? And then what happens at the next step?
Multiply by 2.
Yeah, you take this thing and you multiply it by R, right? So you get AR
Squared.
squared. And then the next thing you do is you multiply by R again, and you get AR cubed, and kind of so forth, right? You guys follow this? This is literally just, oh, I'm just going to write down this idea of starting with an amount and multiplying by a kind of consistent factor of r. Cool?
Cool.
This is what a geometric sequence is. And what we might think about this is we might think A is a starting amount, which lots of like biology textbooks and stuff will call an initial population. And R is just our growth rate. Guys cool with this? All right, let's make some examples.